Welcome to Networks Professionals.
Welcome to this explainer. Today, we're unpacking a massive collision. We're talking about two of the absolute most transformative technologies of our lifetime, quantum AI. We hear about artificial intelligence literally all the time, right? And quantum computing, well, that's always framed as the next big thing. But what actually happens when these two monumental forces finally converge? That is the ultimate question here. What happens when AI meets quantum mechanics? Listen, we aren't just talking about, a faster computer or a marginally smarter algorithm. No way. We're talking about a fundamental paradigm shift in how we process massive datasets. We're looking at a future where we can solve these insanely complex, multidimensional problems that are just structurally impossible for classical supercomputers to crack alone. It's an absolutely massive leap forward. To break this all down, here's our roadmap. First, the quantum AI revolution. Second, how quantum supercharges artificial intelligence. Third, how AI stabilizes quantum systems. Fourth, real-world industry impacts. And finally, number 5, tracking the quantum transition. Okay, let's dive right into this. Section 1, the quantum AI revolution, merging two superpowers. So, to really grasp this revolution, which is being pioneered right now by huge tech hubs like Google Quantum AI and Microsoft Azure Quantum, we absolutely have to start with a concept called superposition. See, classical computers process sequentially. They evaluate one outcome after another in a straight linear line. Think of it like trying to solve a maze by walking down one path, hitting a dead end, backing up, and trying another. Superposition completely breaks that limitation. It allows quantum bits, or qubits, to exist in multiple states at once. It's like navigating that exact same maze by walking down every single path at the exact same time. To put that scale into perspective, a system with just 50 perfectly entangled qubits can represent over a quadrillion states simultaneously. It's wild. This unlocks the ability to process multidimensional data sets at speeds that seriously make our current state-of-the-art supercomputers look like, well, pocket calculators. And this creates a brilliant symbiotic dynamic. It is literally a two-way street. On the left side, quantum powers AI. It gives it this unprecedented computational speed and optimization power, which lets algorithms parse datasets that were previously just way too vast to even comprehend. In return, on the right side, AI powers quantum. It manages the incredibly complex error correction and hardware calibration you actually need to keep a quantum system stable. It's kind of like the ultimate buddy cop movie, right? These two completely different technological partners fundamentally elevate and rely on one another to reach their full potential. All right, let's transition over to the first direction of this two-way street. Section 2, quantum supercharges artificial intelligence, breaking bottlenecks. The first major upgrade we see in this convergence is quantum machine learning, or QML. So, classical AI struggles big time with incredibly high-dimensional datasets. It literally hits a compute wall when it tries to process millions of variables at once. The vector spaces just become way too large for classical memory to handle efficiently. But by leveraging quantum mechanics, QML drastically speeds up model training and pattern recognition. It navigates those massive spaces seamlessly. We're talking about turning weeks of computing time for complex neural networks into literal fractions of a second. Now, think about global logistics and what that kind of speed actually means in practice. We are talking about instantly solving logistical challenges, optimizing massive global supply chains with thousands of moving parts, or calculating incredibly volatile financial portfolio allocations exactly as the market shifts. The real-world efficiency quantum tech brings to complex AI routing doesn't just save a few hours here and there. It reshapes global economics entirely. Optimization problems that would literally take a classical computer millions of years to iterate through, well, theoretically, quantum AI can solve those in near real time. But beyond logistics, we have the holy grail, molecular simulation. Simulating even a relatively simple molecule, like caffeine, for instance, is incredibly taxing for a classical computer. Why? Because you have to calculate the interaction of every single electron. Quantum AI, however, actually operates using the exact same quantum mechanics that govern the molecules themselves, so it can accurately simulate chemical and biological reactions right at the atomic level. This smoothly bridges abstract math directly to human survival, moving drug discovery from years of slow, costly lab trial and error to instantaneous digital modeling. It accelerates the creation of new, advanced materials and life-saving medicines by absolute magnitudes. Okay, let's move to and see how this builds in the opposite direction. Section 3, AI stabilizes quantum systems, the crucial fix. Here's the harsh reality. Quantum qubits are notoriously unstable. The slightest temperature fluctuation, a stray cosmic ray, or even just basic environmental electromagnetic noise can cause what is known as decoherence. That completely ruins a calculation before it even finishes. That's exactly where AI steps in as the required stabilizing force. As the quote here mentions, AI systems, like Google's AlphaQubit, are specifically trained to detect and mitigate these environmental errors to maintain coherence. By using deep reinforcement learning, these AI models predict and correct errors at the microsecond level. Simply put, without AI, reliable quantum computing remains practically impossible. Furthermore, physically building a quantum computer is, well, it's an engineering nightmare. The effort required to isolate qubits at near absolute zero is just staggering. So how do you scale it? You guessed it, you use AI. Artificial intelligence automates the physical design and the agonizingly precise hardware calibration required for these scalable processor systems. AI algorithms can tune the incredibly sensitive control pulses needed to operate the hardware far, far faster and more accurately than any human engineer ever could. Basically, without AI playing the role of master engineer, quantum processors would never be scalable for any kind of broader commercial use.
Let's bring these abstract concepts down to earth now. Section 4. Real-world industry impacts, grounding the tech.
So what is the practical so what here across major sectors? Let's walk through this table. First, in healthcare, as we just explored, we're looking at molecular modeling for patient-specific medicines, where treatments are modeled in real time to fit individual genetic profiles. Next, cybersecurity. Quantum AI detects network anomalies with unprecedented accuracy while simultaneously building post-quantum encryption. And that's absolutely vital to protect our sensitive data from future quantum attacks that could snap current encryption like a twig. Finally, for climate and mobility, we're talking about real-time climate modeling and grid optimization. Optimizing global energy grids to eliminate waste, discovering new battery materials for electric vehicles, it's happening at a scale and granularity that is currently totally impossible. Moving on to our final section and shifting our focus to how we actually monitor this shift. Section 5, tracking the quantum transition, what's next? If you really want to track how quickly this theory is becoming commercial reality, you need to look at current market analysis. These reports are the perfect place to start, keeping an eye on entities like SpinQ, who are actually working on accessible, miniaturized quantum computing, and BQP Sim, who focus on quantum simulation platforms, gives you a front-row seat to the commercialization timelines. Tracking these specific developments tells you exactly when these capabilities are going to hit the broader enterprise market. These aren't just dry academic papers. They track the money, the software infrastructure, and the exact trajectory of quantum commercialization. So I'll leave you with this provocative thought. Are you ready to prepare your organization for the quantum AI transition? Or perhaps you need to dive a little deeper into exactly how quantum machine learning will disrupt your specific industry. Look, this shift is inevitable. Understanding this two-way street between quantum mechanics and artificial intelligence is really the only way to navigate what happens next. Thank you so much for joining me for this exploration.
Thanks for watching.